Okay, we're going to start today not on the front page. I need you to open up your notes, please. So, it says we have two squares that are similar. What does that mean? Same shape, different size. Okay? Today we're going to talk all about similar ratio or similar scales, is what it says on some of your homework problems. What is the similarity, bless you, what is the similarity ratio of these two squares? So, hold on. When you're doing a similarity ratio, everybody underline that, you are comparing the sides. What is one of the sides?
6.
What is the other side? 9. Now, when we're doing this, do y'all remember doing similarity ratio? We did second over first when we did this like in December, right? This reduces. 9 over 6 reduces. What can I divide them both by?
3.
If I divide them both by 3, I get 2 over 3. So this has a ratio of 2 to 3. Or you could say a scale factor of 3 over 2. You just divide the second one over the first one. Do y'all all agree with that? Okay. Next question wants to know about their perimeters. What is the ratio of, underline that, their perimeters? Well, how do you find the perimeter of a square? Add up all the sides, perimeter, not area, perimeter. Add up all the sides, or you can just multiply by. So what is the perimeter of this up here? 24. What is the perimeter of this one right here? 36. What can I divide, the largest number I can divide these both by to reduce this? Divide them both by 12, I get 2 and 3. So, my perimeter ratio is always going to be, not always going to be 2 over 3, but it's always going to be the same as my similarity ratio. Okay? Now, let's look at our area ratio. What is the ratio of areas? How do we find the area of a square? Base times height, or s squared. What is 6 times 6, or 6 squared? 36. What is 9 times 9, or 9 squared? 81. Can I reduce this? If I divide them both by 9, what is 36 divided by 9? 81 divided by 9. And this is my area ratio. Okay, so you see some pattern maybe. Let's do this again. We're going to do this for a parallelogram now. What is the similarity ratio here for these parallelograms? So again, you are going to do one of the sides. You could actually do the height here as well if you wanted to. It doesn't matter. But whatever side, you have to do the same side for both of them. So which side do you want to do? I'm going to do 8 and 10. You could do 10 and 8. Doesn't matter which way you go. So if I do 8 and 10, what do those reduce to?
4 over 5.
4 over 5. Hey, do you notice that's the same as the heights?
Yeah.
And if you were to do the top one, 6 and 20, do you agree? So it doesn't matter which side you choose. So my similarity ratio is 4 over 5.
Yeah.
Does it?
You said so.
Did I?
Oh, but that would be first square.
Well, let's see. How would you find the perimeter of this one?
I don't want
8 plus 16 plus 16 plus 8.
Yeah. Good job. 48. Go with that.
48?
Yeah.
How do we find the perimeter of this one?
20 plus 40.
Oh, I see what you did.
Divided by, I don't know, 4.
What can I divide them both by? 12. And what do I get?
4 over 5.
So, did I have to do that, or could I have just done what Jordan said? What do we know about, oh, I should have done this in a different color. What do we know about our ratios of perimeter and our similarity ratio? They're the same. Every time.
Wait, base times height, that'd be like.
Okay. How do I find the areas of the ratio of the areas? I got to do base times height. What is my base here?
20.
This one, the tall one. I mean the small one.
16.
16. What is my height?
4.
And what is 16 times 4?
Big number.
64.
64.
I just find that now.
For this one down here, what is my base? What is my height? 20 times 5 is?
100.
And if you reduce that, by the way, for those of you that are like, man, they're doing the reducing fast, they might know it, but if you need a little guidance, you can always put this in Desmos and just hit the fraction and it'll do it for you. So just FYI. I wonder if it'll do it if you do the semicolon. No. Okay. So divide them and it'll reduce it for you. What is that reduced? What do they both divide by?
I don't know.
4.
16 and,
16.
wait, so it is the square.
So it is squared. So over here, Jordan was saying, I don't know if y'all had heard him, he's like, hey, if you just square them, you get those numbers. Do y'all agree that also worked here? Okay, let's go to the front of our notes. Does everybody have this written down? I kind of did that really fast.
It's just a genius.
Heard that word a lot today.
You're just a baby.
Wait.
Big pickle pounder.
Yeah, so what's 4 squared? 5 squared. Yep. So, go to the front. If my similarity ratio, remember, similarity ratio is talking about the sides. You're also going to see it talk about dimensions.
That's just size, right?
Dimensions are just sides, the length, the width, the height, the base. So if it says the dimension, the ratio of the dimensions or the ratio of the sides, that's your similarity ratio. If that is AB, what is going to be the ratio of my perimeter? AB. The similarity and the perimeters are the same ratio.
That'll be A squared and B squared
For areas, you square them. A squared and B squared. Now, these are just your ratios. Okay? If it's talking about actually figuring out, you're going to have to do scale factor. So for the area, you would multiply it by B squared over A squared. For perimeter, you would multiply by B over A. You'd multiply it by that scale factor. Okay? So, when you're done writing this down, please open up your notes. Waiting to see all notes open so I know I can move on. Alright, if I'm going too fast at any point, please let me know. This next question, it says the area of the smaller regular pentagon is 27.5. What is the area of the larger pentagon? I want to know the area here.
Oh, so now we have to do scale factor.
So, I'm going to do kind of a chart. Is that okay with you?
Yeah.
So my chart is going to have 3 columns.
Oh God, no.
I'm going to have my similarity ratio, my perimeter ratio, and my area ratio.
This looks like kind of like 30-60.
Kind of looks like a 30-60-90 chart, but yeah. Okay? Which one do we not need right now?
The perimeter.
We're not worried about the perimeter at all. Do y'all agree? Okay. So, what am I going to do here? What's my ratio for my similarity? What?
4 and 10.
2 to 5. Do you agree it's 2 to 5?
Yeah.
But what's my scale factor going to be?
Oh, so it's going to be 2.
Do you agree this is 4 to 10? Wait, hold on. Let me start over. Do y'all agree it's 4 to 10?
Yeah.
Do you agree that reduces to 2 to 5?
Yeah.
But what is my scale factor? What am I going to multiply by?
5 over
5 over 2 or 2.5. Yeah. Does that make sense?
Yeah.
So if I'm multiplying for my similarity scale factor, 5 over 2, what am I going to do for my area?
5 squared over 2 squared.
Times 5 squared over 2 squared. What is 5 squared?
25.
So I'm going to multiply by 25 over, what's 2 squared?
16.
2 squared? 4.
What are we talking about?
Does that make sense? Okay. So, what am I now going to do to find the new perimeter?
25.
I'll sub in.
I'm going to take my old perimeter and do what?
Sub is still it's not there.
Multiply
Multiply it by
25.
25 over 4. So 27.5 times 25 over 4. Please put that in your calculator and tell me what that is. I don't know. Sorry, I have like a random line right here.
What? 25.
27.5. Your smaller area.
875.
What?
171.875.
171.875.
Centimeters squared.
That is my new area.
So how this you know?
Does that make sense?
For sure, miss. For sure.
Let me restate what I did in case it doesn't. My similarity ratio is 4 to 10. I reduced it to 2 to 5. But to find out what I'm going to multiply by, I have to do second over first. So I did 5 over 2. That's my similarity. We're dealing with areas though. So I have to go over to the area column, and what did we do? Square. What's 5 squared and 2 squared? 25 over 4. That's my area ratio. Now I got to take that and multiply it by my original area. And that's how I got that.
So would we always round to the thousands?
That one didn't have a rounding, like that was the perfect answer. It'll tell you if you need to round. Alright, the next one says the area of a rectangle is 22 square meters. So I'm going to draw a rectangle. The area is 22 meters squared. What is the area of a similar rectangle 4 times as large? So now I'm doing a bigger rectangle.
Wouldn't this be 22 times 4?
No. So be careful. I want to know my new area. But what do I know?
That the area is, and it's 4 times larger for the side.
I know it's 4 times larger for the sides. That's my similarity ratio. Times 4. What do I need to find?
You have to find what it comes to.
The area ratio. The area ratio is going to be what? How do I go from this column to this column? Square. So it's going to be times 4 squared, which is what? Times 16. So how do I find the new area? 22 times 16. What is 22 times 16?
A big number. 352.
So my new area is 352 meters squared. Yes. So what do you think people do on accident here to get it wrong?
They don't do that.
They multiply by 4. They forget to square it. If you have area in the problem, you need to square that number. Okay? Next question. Yes. A lot of people multiply by 4 because it just says it's 4 times as big. They're like, oh, the area is 4 times. The area is not 4 times as big. It's 4 squared as big. So we did 4 squared and we multiplied it by that. Okay. Next question. By the way, what if it was talking about the perimeters? You would just multiply by 4. Because remember, the perimeter is going to be the same. If it was talking about perimeter, you would just multiply by 4. Because it's talking about area, you have to square it.
Well, Miss, you have to wait. Wouldn't it be square for the perimeter too?
No. Remember, perimeter is the...
It's the exact same.
It's the same.
Yes. So you would square it because you can't do 4. You can't do times 4 at a time. So,
You only square it for the area. All right. Yeah, if it was asking for perimeter, yes. Okay. 2 similar triangles have areas of 9 inches squared. So So here's my first triangle. My area is 9 inches squared. Please quit talking. And 36 inches squared. What's my time at?
15.
Ooh, we're going to go to 20. The height of the larger triangle is 4. The height of the larger triangle is 4. The height of the larger triangle is 4. What are the dimensions of both? So it wants the base of this and the height, which we know is 4 inches. And it wants the base for this one and the height for this one, which we don't know either.
Well, you have the height, and if you have the area, it'll be 1/2 base on top. So
Okay, so hold on. I'm going to let everybody process. You can write it down. Jordan is right, though. I have the area. I have the height. What do we know about the area formula? Is 1/2 BH. So I can plug in 36 equals 1/2 B times 4.
All you do is times 2 thing, get out of it.
Times 1/2. Times, not 1/2, times 2. Which, yep, and then I get 72 equals 4B, which is divide by 4. What is 72 divided by 4? What?
72 divided by 4. Man,
Thank you. So my base is 18 inches.
Oh, and now we have to do the area squared thing.
Oh, yeah.
How do I do this over here? I don't know anything over here.
Square root it.
You feel like area like you do, but like.
I'm going to do my chart.
Yeah.
Similarity. I don't need my middle one because this isn't asking about perimeter. And do y'all agree? I know the area, it goes from 9 to 26. What's happening from here to here? 36. Thank you. If it's going from 9 to 36, what's happening here to here? It's timesing by 4. But that's my areas. Where does that go? AR section.
Oh, so it'll be times 2 because the square root of 2.
This time I'm going to go backwards.
Wait, no.
Hold on. Let me teach. If you're processing, process in your head. This is my areas because I'm comparing my areas. How would I go backwards this time to the similarity? Square root it this time. Over here, we squared it. To go backwards, I square root it. What's the square root of 4? So that means these are all going to be going this way times 2. Well, what times 2 gives me 18? So this is 9 inches. What times 2 gives me 4? 2. And then, y'all, what can we do with this? Check it. Hey, if area equals 1/2 BH, does 9 equal 1/2 9 times 2? So we know we got it right. So here are the dimensions, and here are the dimensions. In my opinion, that's as complicated as this gets. Yep, I want you to do the last one on your own. This should take you about 30 seconds.
So all we have is oh, okay. 1.5x.
Yes. Doesn't matter. Doesn't matter. I just want to know. I just want to know how much bigger would it be. I don't want to know what the area is. I just want to know how much bigger would it be. So what am I asking for?
1.5
It's not 1.5. I'm asking for the area ratio. So, what's my similarity ratio here? times 1.5 bigger, right?
Yeah.
So what would be my area ratio
2.25.
times 1.5 squared, which is
2.25.
2.25 times bigger is my answer.
Times bigger.
2.2 times bigger. 2.25 times bigger. And that's it. Oh my gosh. I told you if I talk too much, it's hurting. If it's not asking for an actual area, that means if it's asking how much times bigger something is, that's just asking for the ratio. Yes. Okay.
It doesn't really look like a decimal.
All right. For the rest of class, two things. Number one, I want you to glue this onto page 73. This is the last set of notes for this unit.
Wait, is this the last unit of the...
No, we have one more. Yeah, hold on. And then you have homework due before you leave. Right now, worksheet 5, I'm going to open it up. No, hold on. Worksheet 5 in Schoology, go before you leave.